as the first chapter ended with Hubble's statement that universe is expanding and the galaxies are moving away from one another. This was acknowledged by Russian scientist Alexander Friedman. He said that space has no boundaries, nor it is infinite. It is more like a bubble with no elastic limit, and is being constantly expanding its size and reducing its overall density. However, the rate of expansion of the universe, or call it the velocity of expansion, has to beat the gravitational force exerted by the entire mass of the universe in order to avoid being collapsed at a point through contraction of the universe. But the entire mass of the universe was less than 1/100th of the amount required to halt the expansion of the universe, even in the lowest estimate of the rate of expansion. This argument gave rise to the concept of dark matter, which gives the mass to the universe in order to maintain expansion and avoid being fall at some point. It was Alexander Friedman who gave the idea of the Big Bang theory, and said that it was the event of the Big Bang which gave birth to the time dimension. He said that it was important to view the entire universe through not just three-dimensional space, but adding time as the fourth dimension, hence giving rise to the term space-time. In 1783, a British philosopher and scientist John Michell gave the idea that if a star is sufficiently massive and compact, then it exerts such a strong gravitational field around it that even the light could not escape. As the light is both wave and a particle and is affected by massive gravities, he said that even if we can't see such massive bodies, we could still be under its gravitational influence. It was also important to understand how stars like the Sun are formed, in order to understand the nature of the black holes. In simple terms, stars are formed when large amount of gases starts to collapse in on itself due to its gravitational attraction. This contraction is at the atomic level, and tremendous amount of energy in form of heat is released in this process. The star will remain stable like this for 1 million of years, with the heat from the nuclear reactions balancing the gravitational attraction. Then after some time, one of these forces will overcome the another, and either the star will collapse under its gravity or will explode. In the year 1928, an Indian scientist named Subramaniam Chandrasekhar came up with the term Chandrasekhar limit. He stated that if the star mass is less than 1.44 times the mass of our Sun, collapses under its gravity to become a white dwarf star, it won't be stable enough to later become a black hole when it runs out of fuel and energy. Any star greater than 1.44 times the Sun will eventually lead the star to collapse in its gravity, leaving behind only the core of the star as the remains of the star, hence turning into a stable dwarf star or a well-stable neutron star, which later turns into a black hole. These neutron stars are constantly pulsating radio waves in form of pulsars, because of complicated interaction between their magnetic field and surrounding matter. They are densely packed neutrons with no electrical charge and can have the weight of billions of tons within a couple of cube meters. They can have a gravity of more than billions of times of the Earth, even after have the size way smaller compared to the Earth. But the formation of the black hole depends on the circumstances that this neutron star goes through. If this neutron star is too much isolated and never gets in a collision with other bodies to gain mass, it will die off by simply cooling off. But if the neutron star gets lucky and consumes enough bodies to increase its overall mass, then later it will again collapse in its own gravity, and will create a puncture in the space-time fabric, resulting into the formation of a black hole. The gravity of this black hole is so strong that the light cones get bent inwards more and more, and the light can no longer escape the gravity. It means there is a point where the light can be seen, but as it reaches a boundary of no return, called as event horizon or singularity, the light fails to return. That's the reason a black hole has a ring-like structure around it. The strength of the gravity of the black hole depends on the size, its overall mass, as well as its rate of rotation of the star which got collapsed and gave rise to it. Black holes are one of the cases where its scientific theory and its mathematics was developed in detail before there was any evidence of it.